Well, it's another day and another project. I wonder what this one is. Well, the answer to that would be this is a Raspberry Pi Zero W, and this is a no IR Pi camera. This is a 7805 voltage regulator, and this is a bridge rectifier, designed to run on a range of voltages, and there's no chance of getting the polarity backwards. So why am I doing all this? Well, I have past all the junk over here. There is a footpath that runs right past the front of my house, and on that footpath I have an IR beam, or rather across the front of the property, and it goes off at strange times of night. So I'm trying to figure out exactly why that is. So this little guy is going to get shoved in a nice neat little box which I've designed here, and I'm going to 3D print that little box and mount it all in there. That's then going to get stuck on the fence, and it's set up to write me a script, or more to the point, there's a script set up to write me a CSV file that will log the date and time of every motion event, and also grab a snapshot. And once I have my answers as to what's causing it, I'll pull the camera down again. It's probably not the best to have a camera pointing up the footpath. I'm sure that probably violates some kind of rule or regulation somewhere, but this is only a temporary setup just to experiment with the idea. So you can see here where I've done my usual process. I've used AutoCAD here to make my 2D design. I've pasted that as a sketch into Inventor, which I find easier than drawing my 2D sketches in Inventor. And I've converted that into this nice little shapely box here, which is, I've got some little bosses in here to take those little 3mm threaded inserts, and there'll be a lid going on the back, and the lid on the back, as you see from here, has been designed to accommodate that heatsink. And I've then gone to plot the whole thing up in this screen here, so I can run that through the 3D printer. And it looks like that in my current settings is only going to take about 17 meters of filament, which is not too bad. So we'll see how we go. We'll get this printing and see what we can do. This is a bit of a messy 3D printing area, but I thought I'd just show you a couple of the tips that I use for 3D printing. I use a cheap-ass hairspray on the bed, and I just give it a quick little spray on the glass bed. It's a whole lot easier than Captain Tape and all the other crazy things I've seen people use. A little thing I did do off screen, usually I've got several of these glass plates, and I give them 3 or 4 coats of hairspray out in the sunny weather before I initially start printing with them. So that we've got to get this all warmed up, and it looks like my filament has snapped. This crazy extruder is an absolute pain. I need to redesign it. I have to pretty much disassemble this anytime I want to put new filament in there. So I'm going to be here for about an hour doing that to get everything set up and calibrated again. Once we've done that, I'll start filming again, and you'll see the 3D printing in process. Now, probably one important step I should do before I go much further, because I'm using a Melzi board, or a Melzi board, I forget how to pronounce that, on a RepRap 3D printer, it is inclined to drop out when I'm running direct from a PC link. So I'm going to compile my G-code and save it onto an SD card first. That way, it doesn't matter what happens to the computer, my print's going to continue without interruption. Well, the plot thickens. If you can see what's going on in here, I have the extruder apart, and the filament is PLA that's been out in the air for a while, and it's got very brittle, and of course it's snapped off inside the extruder. This is going to take me a while. Alright, after about 25 minutes of mucking around, we finally have some success. Got filament coming through nicely now, in nice decorative little curls. See how we go. We'll pull that away. Alright, time to get cracking. Alright, moment of truth. We're starting the job. We should see here it will have turned the heat bed on. Will start to increase in temperature. Alright, so while we're doing that, let's have a look at some other aspects of the design. Okay, so let's have a quick look at why I've done what I've done here. Now, the LM7805, if you're unfamiliar with this thing, is a 5-volt linear regulator. You can feed it about 28 volts, I believe, in, and it'll bring it all back down to 5 volts. There's a whole series of these. There's a 7812 for 12 volt, there's a 7809 for 9 volt, and there's a whole range of different voltages. I think there's a 3 volt one as well. You'll find the partner to these, the 79 series units, which are a negative regulator. You'll find a lot of those in cheap computer power supplies because they regulate, they keep a common positive and regulate the negative up and down. These guys have a common negative and regulate the positive side. I've stuck a bridge rectifier in here simply because I can feed in any polarity I want and it'll correct it for me. Usually used in power supplies to convert AC to DC, but in this case I'm pulling a bit of trickery, hence why there's no capacitor involved. I have soldered it directly onto the 5-volt rail of this Raspberry Pi here with some cable that is drastically oversized for the task. Originally I had intended to hide this in a very, very thin package, hence why I've gone down that route. Plans have changed during the build and basically I got lazy. But let's plug all this in and I'll discuss a few things while we're doing that. Let's give ourselves polarity. You're noticing that I'm not really caring about the polarity here. It should work. Now that we're connected, I believe we should have a green light here. There's our little green light. You'll also notice that in the settings I've told it to turn the LED off for the camera. I don't really want it attracting a lot of attention to itself. So now we've gone over the electronics a little bit, let's go and have a look at the programming and see how that happens. I'm going to jump back to the printer here for a moment as it was warming up in the background. One of the things, it's just heated up the bed. It's come up to about 40 degrees. And yes, there is a bit of junk on the bed here at the moment. There's a bit of dust. This is not going to be a high accuracy job. What I'm waiting to do at the moment is the hot end is heating up. The bed is already warm. When it's connected, because this doesn't have common linkages between these two Z-axis standoffs here, it can get out of whack a little bit. So when it first does its print here, I've got to just adjust a left and right occasionally. Although this looks pretty good, it stayed in sync fairly well. So I have it print a few laps and then do a brim on the first part of the print. And that gives me an opportunity just to adjust the Z-axis height from each end. I am redesigning this printer at some point and I'll be putting a chain link between those two Z-axis. It looks like I haven't needed to do too much calibration at this point, so I think we're pretty good. Alright, let's go back to programming. Now, apologies for the lack of screen capture here. It's a holiday. It's actually Easter Saturday today, so I'm a little bit busy. Anyway, first thing we want to look at, this is I'm connected to the Raspberry Pi over Wi-Fi using SSH. Now, what I've done here is I've made a couple of scripts. I've run a shell script, which, to be honest, I could have run that straight out of the motion conf file, but I wanted to be able to edit it. So basically what happens, we have, this is the motion configuration file for the piece of software I'm using to control the motion detection, ironically called Motion. I'm having it start in daemon mode, so it suppresses to the background on boot. And I'm using the cron schedule to start that at reboot, just so I can run it with admin privileges to avoid some of the problems I had at the startup. We can scroll through a lot of these settings in here. I'm going to see if I can find the one I want. For a start, it's a little 5 megapixel sensor, so right here I've set the width and the height to about as hard as it'll go, and I've told it to take 4 frames a second just to keep the processing and the power usage down a little bit. I don't need to be, doing 4K video or anything with the thing. I've also set up web access to it, which is down in here somewhere. Motion detection, I've left auto tune on and despeckling as well. I'll go down a whole bunch of other things here. I turned auto brightness on. I've also set it to compress the images to 75% quality. Most of the settings here are the defaults. I'm not doing video with it. The text display, I've had a bit of a muck around because I'm an Aussie and not an American, so we go day, month and year. And I want the time on there as well, and a frame count so that I don't get duplicate file names and errors. So that's handy. I've also got it telling us that it was from my footpath camera here, and I'm putting text doubling on because the resolution is so high. I've set up the target directories to save it to a file in the home, or a folder in the home directory. So that is useful. A bit of redundant terminology there, folder and directory. And most of that is all setting the same. I'm letting it run a server on, or a HTTP server on port 80 just because it's easy. Normally it's 8081, and I'm setting up the administration port on port 8080 down here. So that's kind of handy. So yes, we've got all the other values are pretty much the same. I'm not doing any pan tilt. That's all more or less correct. Somewhere in here, which I probably can't find at the moment, I have it run, when it detects a motion event, I have it run this detect shell script. Now that shell script, if we can open that here, basically does something really simple. It opens up a file that I'm naming as CSV for comma separated values, which in Windows will open as an Excel spreadsheet. And it's just chucking the date and time into that and appending it. So we end up with a list of comma separated values, such as this file here. We load up Excel here. We can see that the last few events that logged have gone in here. I've got that recording a motion event is defined as an event that lasts for less than 15 seconds. That means it won't re-trigger inside 15 seconds, which is handy. I don't end up with 1,000,001 really close records. Originally I was having it record to a text file. I found CSV is a little easier. Now all of this has been set up to work over Samba sharing, so I can access both this script folder and also the image files from Windows over in Network Share. That's very handy. It means also from a Windows machine without an SSH terminal, I can easily get in, make an alteration to the script and change its behavior on the fly without having to go through the rigmarole of starting an SSH session. Although from where I am, it's not going to be a huge issue. The next thing I am going to need to do is to run Raspberry config. I'm going to disable the onboard Bluetooth, and that will help with some of the, hang on, I need to cancel out of this. Disabling the onboard Bluetooth will help a little bit with the coexistence with the Wi-Fi, helps keep my signal a bit more stable. I've also got a long-range outdoor access point on a 40-foot pole. That should mean I can place it pretty well anywhere on the property. So we should be cooking with gas here. But let's jump over to the next bit of the project, and we'll have a quick look at like this cron schedule and whatnot. So what I'm doing here, I'm just going to go over to the root cron tab because I wanted it to run with root privileges, and I've just got running at reboot here, running the motion program and suppressing the errors, as well as dumping it all to nowhere. Because I don't really care about the errors, I'll enable that if I've got a problem. So that's our cron happening there. So let's jump over to having a look at this on the Samba sharing and see what we can do with that. Now, I know it might be a little frustrating, you can't see all the numbers over to the left there, but one of those is a connection to a direct connection, which I'd rather not have the IP publicly accessible here. But we can see from this, I've set up a network drive for the unit, and I can access all the images directly. However, I can also go down to Footpath Cam here, and I can access my user directory to get access to all this other stuff. That does require a password. I just have it saved, so no, it's not quite the security risk you think. It's also worth noting I've changed all the default user passwords, even for like the SSH console and everything, just because I don't really want my network getting hacked. But we can have a look at an image here. We might even be able to see it. That's right, this morning I had auto brightness off, so well, we can see the little flag down there. And it was indeed from Footpath camera. We actually couldn't see anything. I turned it on in the middle of the night and it hadn't adjusted its intensity control, so we'll fix that, or I've already fixed that, but we'll have a look at some images once we've got it actually happening. And we can see the first couple of layers going down on the 3D print here. It's looking fairly good so far. I'm hoping I've got enough material up here. This is my roll. I hope that's 17 meters. I really just really just guessed it. So I need to print or laser cut myself a better spool holder too. But you know, we make do with what we can. Well, the print is progressing very well. I think I'm just going to make it with the filament. I've got a tiny little bit of filament left on the reel, but I'll probably get this one last print out of it, which is good because it's been out of its package for far too long. So we're almost there. It's a bit hard to see with the lighting in this little 3D printing hutch, but yeah, it's getting there. It'll be soon for the assembly. Alright, so the print's mostly finished here, but it's very heavily stuck onto the bed. Now, tip if you're using hairspray is patience, literally that. I'm going to go and turn on the cooling fan on the back of this, just leave it on this for a few minutes, and it will, it's stuck on hard now, it'll just pop off when it's done. So we'll be right back. Been about 20 minutes of waiting, and I just heard a crack. If we push gently, it'll pop up off the bed. No force required. I'm happy. Alright, so I've got my parts printed and removed, and immediately I've spotted a problem. When I've gone to insert this heatsink, there's a lot of slack in here, and I've forgotten to put in a hole to run the cables through. So I'm printing a new lid. In the meantime, I'm going to get the rest of this stuff assembled, and it's going to be a temporary design, so I'm not sure if I'm going to actually fix everything in here. I'm probably just going to glue it in, or maybe even just use blue tack. We'll find out. The important thing is I need to get my threaded inserts and melt them into these holes now. So let's go and do that. Okay, so the way I do this is a little agricultural, but I've got my existing holes here that should be just deep enough, and I'm going to use a screw as a locator. I'm going to put a threaded insert on there, and I'm going to drop that in. Now often I need to put two of these together on the one screw so that they can lock each other together, and that way I have a little bit of an easier time manipulating them in the hole. The next step is to hold them in some pliers, and I'm going to heat them up with a gas torch. It's a little baby gas torch. That should be more than enough to sit into the plastic. And then we just drop it down here with a little bit of pressure. I think that's about right, and I'll just hold here till it cools off, which can take a couple of moments. I'll pull my pliers out, and we'll get a screwdriver. And that should, if we've done everything right, come out of the threaded insert, and we've got a beautiful little threaded insert in the hole there. So I'm going to do that to the rest of these off camera, so I'm not so distracted, and hopefully I'll get them all right. Alright, well, I've got these threaded inserts in, and some of you might realise what I'm cutting up at the moment. I'm making some little cardboard insulators to go in between the camera and the main board, and also the heatsink. This just makes it very easy to remove when I want to remove this later for modifications. I realise I've made my piece of cardboard a tiny bit too long. Here we go, and that should fold in the top like that. And I'll be doing another layer in a moment. We'll just continue on to fitting this all in the box and see what else we can do. Well, I'm nearly finished printing. I've got a minute and a half to go, and this was a quick print, so I did it direct from the computer without having to save it to an SD card. So we're just at the moment keeping track of where it reckons it should be printing. And I've got everything else more or less sorted out here. Got some zip ties to go through the flanged holes. You really can't tell, there's a camera lens here on this camera. Part of that is by design. Alright, so the new back panel has been printed and the heatsink fits almost perfectly. You might see a little bit of an air gap there. I've got a solution for that which I planned from the start. I've also insulated the pins on the bridge rectifier, and this should go together fairly soon. So we're almost there, almost to smoke test time. I have some aluminium tape here I'm going to be using to seal the heatsink in, both for its thermal properties, but also it's exceptionally good at weatherproofing this stuff. So we'll be sealing up the gaps around the heatsink with this. I might even make a little gasket to go under the lid, but I think being the temporary nature of this, I'll probably be using blue tack or something along those lines to do the job instead. I'm just using scissors here to cut some little strips of the stuff as I go. I'm hoping this should add just a little bit of extra heatsink capability to the design. There we go. I'll have to squeeze a little bit in under here to help get that covered. So we'll be back shortly and I'll have the lid on and hopefully we'll be able to test this. Okay, so we're mostly assembled now. We have a heatsink on the back and our camera on the front. Unfortunately it might attract a little bit of attention, so we'll need a little squirt of spray paint. I'll stick a little bit of tape over the camera lens here. I'll give it a quick dusting of spray paint. I'm trying to make it look matte finish and beaten up and inconsequential. If it looks all shiny and new and it gets seen, might be subject to some vandalism. And yes, I know this looks like a hidden camera. That's pretty much what it is. It's not going to be left in a public place. It's on private property here. Just trying to find out if anybody's trespassing, and if we find out that they're not, we're going to rip it down as soon as we figure that out. So here we go, we'll go put some paint on it. Okay, so we have the unit mounted here. This unit here is my doorbell unit. I don't know if you'll hear it if we cross the beam here. I don't know if you could hear that in the background, but it sets the doorbell off. This little guy here, which we've just created, should keep an eye down the doorbell beam. Be able to find out who's been sneaking across it in the middle of the night now. So yeah, let's see how she goes. So it would appear I've been SMART and put it upside down. Maybe I should have spelt that SAMRT in reference to The Simpsons. Well, I've got to go out and position it the other way up again. Okay, well I've got a slightly wider view of the street than I had expected, so I'll probably do some adjusting later, but for now this is going to have to suffice. And you can probably see from here I've got it running over an IP connection, which is not too bad. I do need to find a way to increase the tag size a little bit. It's tiny, but at least I should have some idea of what's crossing that beam in the middle of the night. And we can also see that I've got auto brightness control enabled, and that red box, which determines the motion detection area, is detecting motion when there is none. So I may have to fix that. And also, yes, you probably noticed the colors don't look quite right. That's because there's no infrared filter. So we're seeing things very much as they are unfiltered. But yes, I better go fix that problem. So all I'm going to do here is where it says auto brightness, I'm going to make that off. And then I'm going to save, yes, and I'm going to do a sudo reboot and restart the whole unit. Right, and we'll see that in a few minutes. Well, that leaves the project pretty well done. I've been out and flipped the camera up the right way round and made some adjustments, and I'm starting to see a whole list of dates and times when motion is detected. And that's the key information that I really want. I don't really care too much about the photos. I just want to find out when the traffic occurs so I can graph it. That way I might be able to actually figure out what's going on. So yeah, this will be interesting to see how this experiment works. I might even do another video shortly before I pull this out of service. But yeah, I hope you've enjoyed this video, and if you've got comments, I guess, make comments. Well, I'll try my best to answer them, and I'll try my best to keep the trolls out of it too, because it's the internet, and that's life now, apparently. Anyway, I'll see you all next time.